all the chapter 5 My Math Labs, I'm gonna be incorporating like problems from like the last sections as well, we talked a little yesterday about how the main challenge with all this rational expression stuff is really just like figuring out like what to do when, like for specific types of problems. So if so tonight there will be simplifying and multiplying and dividing along with your addition, subtraction. That way you guys have some practice, like seeing multiple types of problems and figuring out which is which. Like it'll be on the test, right? Because on the test we don't have like a day to correspond to for every test problem. So just be on the lookout for that. They're not all going to be exactly like what we do today. Some will be like what we did yesterday. Office hours right after class today. So today we're talking about adding and subtracting rational expressions. So we're going to start with, maybe I should find my notes. They're there. We're going to start with finding LCM. So do you guys remember how to find the least common multiple of a bunch of numbers? Like for example, let's see, we're finding the LCM, which is the least common multiple. Somebody swing that door shut for me, please. Thank you. So let's find the LCM of like 18, 54, and like 30. Anybody remember like from 065 how to do that? What do we do?
Don't you see the biggest number that can go into both of them?
Right, so you're thinking of GCF. So GCF is the biggest number that goes into all of them.
Oh wait, no, you make the factor tree and then you take the numbers and multiply all of them.
Right, so GCF is the biggest number that goes into all of these numbers. LCM is the smallest number that all these numbers go into. Right, so yeah, we use prime factorization. So we say 18 is 2 times 3 times 3. 54 is 2 times 3 times 3 times 3. 30 is 2 times 3 times 5. And then we build our LCM from that. So in order to be a multiple of each of these numbers, a number has to contain all of the prime factors from each of these factorizations. So we start with just the factorization of one of them. It doesn't matter which one. I always just start at the top. And then we move on to the next number and we say, okay, is there anything in this factorization that I don't already have in my LCM? Yeah, there's a 3, right? In order to be a multiple of 54, I have to contain a factor of 2 and 3 factors of 3. I already have a factor of 2 and I have 2 factors of 3, so I need another factor of 3. And then how about from here?
5.
I need a 5, right? Because to be a multiple of 30, I need to contain a factor of 2, a factor of 3, and a factor of 5. I already have a 2, I already have a 3, and so we need one more, a factor of 5. And so, like, you always know you have a common multiple if you can find each one of the individual numbers in that factorization, right? So, like, here's 18, here's 54, and then there's 30, right? So within our LCM, we can find each of the individual factorizations. It's okay if there's overlap, but and then we know that it's the least common multiple if we don't have any extra factors in there that we don't need, right? Like if we had an extra factor of 3, we don't need an extra factor of 3 in order to contain all of the factors from each of our numbers. And so that's how we know it's the least common multiples. We don't contain anything that we don't need in order to get all the factors from each one. So when we find the LCM of polynomials, we're going to use the same exact approach. So if I want to find the LCM of, let's say, x squared minus 1 x to the 4th plus 2x to the 3rd plus x squared and 5x minus, 5x squared minus 5x. So just like we talked about yesterday, we want to think of each one of these polynomials as one of the whole numbers, right? So we don't want to look at individual terms. This is one number, this is another number, and this is another number. So that entire thing needs to be factored. So we never want to do like prime factorization of individual terms. We want to factor that into the entire thing as a polynomial. So we're going to start with x squared minus 1, which is equal to x plus 1 times x minus 1. So that's my first factorization. And then we have x to the 4th plus 2x to the 3rd plus x squared. So I can factor out a GCF of x squared. I get x squared plus 2x plus 1. And then from there, remember yesterday we talked about how we were going to treat those monomial factors just like whole numbers. So we'll do prime factorization for that GCF. So that's x times x. And then x squared plus 2x plus 1 factors as x plus 1 times x plus 1, which I just got by doing the AC method. So this is my second factorization for my second polynomial. And then the last one, 5x squared minus 5x. Well, I just have a GCF of 5x. So 5x times x minus 1. So that's my third factorization. And so now we're going to build the LCM the same way we did with the whole numbers, right? We're going to start with the factorization of the first one. So my LCM will start with x plus 1 times x minus 1. And then if I look at that second factorization, the one in pink, are there any factors there that I don't already have in my LCM?
Just x by itself.
How many?
2 of them.
Yeah, so I have 2 factors of x. So x times x. Is that all?
X plus 1.
Yeah, I need another x plus 1, right? Because in order to be a multiple of x times x plus 1 times x plus 1, I have to have 2 factors of x and 2 factors of x plus 1. So I have 1 factor of x plus 1, then I have these 2 factors of x, so I need 1 more factor of x plus 1. And then what about that last one, the one in blue? Are there any factors that I'm missing? So is 5x a single factor? What does 5x mean?
5 times.
It's 5 times x, right? So what am I missing?
5.
Just the 5. Good. So and if it helps, you can put like the dot between these guys. We're so used to thinking of 5x as all one thing, like when we do like adding and subtracting and combining like terms. But when we're thinking of it multiplicatively, those are 2 separate factors. So we can see, again, just like we did with the whole numbers, that we can find all of our factorizations within our LCM. So x, 2 factors of x and 2 factors of x plus 1. And then here's my 5x and x minus 1. So we can find each of those within our LCM, which is what tells us that our LCM is a multiple of all of them. If we weren't able to find one of those complete factorizations in there, we'd be missing something. So far, so good? Okay, so let's use this idea to add and subtract. It actually turns out that actually finding the least common denominator is usually a little simpler than these problems where we find the LCM, because we don't make ones that have like 20 factors. So let's start with one where we almost have common denominators. Let's add, what did I say I was going to do? 3 plus x over x plus 3 over negative x. So if there's addition or subtraction in the numerator or denominator, remember we put that in parentheses. And then I'm going to use, so one thing that can get tricky is when we have negatives in our denominator. So there's a couple ways you can approach this. You can decide that your denominator is going to be negative x, but I find that to be pretty cumbersome, because then you have to like introduce all these factors of -1, right? To make like the denominator negative x, we would need like -1 down here, which means we'd need -1 up there, and then we have all these negatives floating around. But instead, I'm just going to remember that like 3 divided by negative x is the same as -3 divided by positive x. Right? Like if you have a fraction with a negative sign in it, it doesn't matter where that negative is, right? Because like, for instance, like -10 divided by 5 is equal to -2, but then so is 10 divided by -5. Right? It doesn't matter where the negative is. If you divide a negative and a positive, you always get the same thing. Does that make sense? So I'm just going to move that negative to the numerator. So I'm going to say that instead of that 3 divided by negative x, I'm going to write it as -3 divided by positive x. So we have 3 plus x over x plus -3 over x. And now I have common denominators, and I didn't even have to do a lot of work, and I didn't have a bunch of extra negatives floating around, which can get kind of tricky. So when we get common denominators, remember we keep our common denominator and we add our numerator. So I have 3 plus x plus -3 over x. And I have nothing to distribute here in front of that 3 plus x, so I can just drop those parentheses. You can think of it as a positive one if it helps to actually think of distributing something. So this is 3 plus x plus -3 over x, which is x over x, which is 1. Right, because 3 plus -3 is 0. So what if we don't have common denominators? So that's where finding that LCM is going to come into place. So let's do 2x over x plus 2 plus 3 over 2x. So rules for getting common denominators. So to get common denominators, can I fit it? Nators, there we go. Whoa. There are 2 rules. The first is that you can only use multiplication. And then the second is that you can only multiply by 1. because otherwise we would change the value of our fractions. So this process is essentially unsimplifying fractions. So instead of, like yesterday we factored and then we canceled off any factors that were the same. Instead of canceling those factors, we're going to reintroduce factors that are the same on the top and the bottom to make the denominator what we want it to be. Addition, subtraction in my denominator means it goes in parentheses. And then I always start just by like setting it up, and then I'll figure out what to multiply by. So I'm going to take 2x over x plus 2. I'm going to multiply that by some fraction to get common denominators. And then I have 3 over 2x, which I'm going to multiply by some fraction to get common denominators. What are the factors of my first denominator? What is my first denominator?
X plus 2.
And what's being multiplied to get x plus 2? Is there a factor of x? Is there a factor of 2? Is there a factor of 9 million? So is x plus 2 equal to 2 times something? So x plus 2 doesn't have a factor of 2, right? What factors do I have in my denominator? Sure, there's always a factor of 1. And what else?
X plus 2.
Yes, x plus 2 is a factor. Do I have that factor in my other denominator?
No.
I do not. So I need it, which means I'm going to multiply by x plus 2 over x plus 2. What factors do I have in my second denominator?
2x.
Yep, 2 and x, right? Do I have a factor of 2 on the left? So if you think there's a factor of 2 on the left, ask yourself, like, what are you multiplying 2 by to get x plus 2? Because that's what it means for x plus 2 to contain a factor of 2, that you can write x plus 2 as 2 times something. Can you write x plus 2 as 2 times something? So does it contain a factor of 2? So then we need one. Does it contain a factor of x? So is there something I can multiply x by to get x plus 2? So we need one. So now both my denominators contain 3 things, or 3 factors. They contain a factor of x plus 2, they contain a factor of 2, and they contain a factor of x, which means now I have common denominators. Once you get common denominators, you're going to add the numerators, right? So we have a common denominator of 2x times x plus 2. And then I have 2x times 2x plus 3 times x plus 2. Can I cancel anything at this point?
2x.
So is 2x a factor of the numerator? Is the numerator factored? Is it a product? I see head shaking. Why not? Daniel, why isn't it a product?
The numerator,
Yeah.
because you have to put everything together.
What do you mean?
Because you have to multiply 2x together, then distribute 3x
that make it a product? So when we simplify, does that make something a product? You're right, we have to do that, but why isn't this a product?
Because there's no equals one.
So product has to do with multiplication, not equals. Feel free to leaf through your notes about products. We spent a bit of time talking about what makes something factored form or not factored form. What makes something a product?
There's no plus or minus outside of parentheses.
Yeah, the main operation is multiplication, right? So it is something times something times something times something. This is something times something plus something times something, right? It's not all multiplication. There's addition, subtraction, well, in this case, just addition, outside of the parentheses, which means that the numerator is not a product, which means that we can't cancel anything. This is like if I had, if I took like 5/10 and I wrote it as 2 times 2 plus 1 over 2 times 5. I mean, that's true, yeah? But I can't do that because 2 is not a factor of 2 times 2 plus 1, right? Like, it's not a factor of the whole thing, and so I can't go canceling it. The same is true over here. 2x is not a factor of 2x times 2x plus 3 times x plus 2. It's only a factor of the first term. And so we talked yesterday about how we can't cancel things unless it's fully factored. So in order to get a factored numerator and a factored denominator, because we have this addition, we're going to have to simplify first and then factor. So we have 4x squared plus 3x plus 6 over 2x times x plus 2. And so then we'll try to factor that numerator. So my AC is 24. My B is 3. That would mean that everything has to be positive. And there are no numbers small enough that multiply to 24 that they're going to add to 3. Right? Because, like, I have 1 and 24, 2 and 12, 3 and 8, 4 and 6. All of those add to numbers that are way bigger than 3. And so that means we're done. So our basic process here is to, let's do one more here. Let's do this one. So 2x plus 1 over x minus, or x squared minus 7x plus 6 minus x plus 3 over x squared minus 5x minus 6. So just like we did before, there's addition, subtraction in our numerator and or denominator. We put it in parentheses. So then the first thing we have to do is, well, our goal is to get common denominators, which means we need a least common multiple, right? So what was the first thing we did to find a least common multiple? Yeah, we factored both the polynomials, right? So we're going to start by factoring the denominators only. And the reason I'm only doing the denominators is if you look back at the example we just did, we had to expand this whole numerator in order to simplify it down, right? And so if I were to factor the numerators first, then when I get to that step where I expand them, I'm just unfactoring. So there's no point in factoring the numerators until we actually get to do the addition. So in this case, we have 2x plus 1 over, this one factors as x minus 6 times x minus 1. I'm just doing the AC method. You can do it the long way, but I'm just saving a little time by doing it for us. So this one is x minus 6 times x plus 1. So we've factored our denominators, and our next job is to get common denominators. So we want to get common denominators. And so in order to do that, we're going to have to multiply by factors of 1. So we've got our 2x plus 1 over x minus 6 times x minus 1. We're going to multiply that by something. And then minus x plus 3 over x minus 6 times x plus 1. We're going to multiply that by something. So I always start with thinking about what we already have in common. So they both already have an x minus 6, so we don't have to worry about that. And then, do they both have a factor of x minus 1? They do not. I have a factor of x minus 1 here. But I don't have one over here, so I need to multiply by x, not plus, minus 1 over x minus 1. And now they both have a factor of x minus 1. Are there any other factors that I need to take into consideration?
X plus 1.
Yeah, there's a factor of x plus 1 right here, which I don't have in my first fraction. So we're going to multiply by x plus 1 over x plus 1. So now both fractions, both terms have a factor of x minus 6, a factor of x minus 1, and a factor of x plus 1, which means I've got my common denominators and I'm ready to combine. So our next step is to just add and or subtract the numerators. So at this point, all you're doing is copying the numerator. You're not actually doing any calculations. So we have our common denominator, and then you're just going to take this entire thing and write it as the numerator of your fraction. Whoa, that did not work out very well there at the end. There we go. So we have 2x plus 1 times x plus 1 minus x plus 3 times x minus 1. Can I cancel anything?
No,
Why not?
because of the subtraction.
Yeah, it's not a product because of that subtraction. In this step, do not cancel. If you find yourself crossing things off right after you get common denominators, then something is going wrong. So our goal here is to get a product in the numerator and a product in the denominator. So the denominator is already a product. You guys see that? So I don't have to do anything else in the denominator. I'm going to simplify the numerator. So we're going to distribute and combine like terms. And the reason we're doing that in the numerator and not in the denominator is because the numerator is not a product and the denominator is a product. So there's no way we're going to get that numerator to be a product unless we first make it into a simplified polynomial that we know how to factor. So we have 2x squared plus, so 2x plus x is 3x plus 1. And then I'm subtracting, so whatever I get when I multiply has to go in parentheses because I have not distributed that negative yet. So I get x squared, and then negative x plus 3x is a positive 2x, and then minus 3. Yes?
If you just distributed the subtraction in the middle, like instead of simplifying, would that just replace it with a positive, or would that make it a product?
It would make it addition. But like you can only distribute like you could write it as 2x plus 1 times x plus 1 plus negative x minus 3 times x minus 1, like that. But there's no way to make subtraction into multiplication. You can make subtraction into addition by like adding the opposite, but you can't, it won't ever turn into multiplication. So this is over my common denominator. And then to combine like terms, I have to distribute that negative. So we have 2x squared plus 3x plus 1 minus x squared minus 2x plus 3. All over our common denominator. Oh, that's very large. Make it smaller. Okay. So now we're ready to combine like terms. We have 2x squared minus x squared is x squared. 3x minus 2x is x. And 1 plus 3 is 4. All over my common denominator. So now my numerator is fully simplified. I can think of it as a single polynomial, which I'm now ready to factor. So that's my next step, is to factor the numerator. And then once I factor the numerator, so after step 4, all we're doing is what we did yesterday. We're getting a factored numerator, a factored denominator, and canceling common factors. So cancel common factors. If you find yourself slashing out anything before the very, very last step, then you're probably canceling something that you can't cancel. So that's a good thing just to keep in mind, is like the actual canceling of anything from the numerator and denominator is the very last thing that you do. So one way you can sort of organize all of this is the first thing you do is work only with the denominators. So factor the denominators, make them the same. And then you're working only with the numerator. distributing, combining like terms, then factoring, and then you get to do something with both. So all denominator, all numerator, and then cancel if you can. In this case, x squared plus x plus 4 doesn't factor because there's no two numbers that multiply to 4 that are small enough to add to 1, right? Everything's positive, so we'd need two positives, and 1 times 4, or 1 plus 4 is not 1, and 2 plus 2 is not 1. So there's, when your b is 1 and everything's positive, most of the time, well, all of the time, it doesn't factor because you need at least a factor of 1 and a factor of 1 to get any number when you multiply, right? So let's do another one. Let's do, we'll say 2x divided by x squared minus 4 plus 5 over 2 minus x minus 1 over 2 plus x. So, as usual, any addition, subtraction goes in parentheses. So our first job is to factor those denominators. So this factors as x plus 2 times x minus 2. And then remember, just like we did yesterday, we want descending order, positive first term. So that 2 minus x, we would have to write as negative x plus 2, and then do what? What did we do with these yesterday?
Switch them around and make it so it's negative, it's x minus 2 instead of 2 minus x.
So how do we switch it around?
You times it by negative 1.
We factor out a negative 1. Yes, good. So we can't actually multiply by anything because that changes its value, but we can pull out a common factor. So this is the same as negative 1 times x minus 2. Just like when we distribute a negative, pulling out a negative changes the sign of both terms. So that gives me negative 1 times x minus 2, and then I've got my 5. And then if I want to make that x plus 2, do I need to pull out a negative? That 2 plus x? No, addition is commutative, right? So 2 plus x and x plus 2 are exactly the same thing. So I'm just switching the order. The reason I had to pull out a negative over there when I switched the order was because it made my first term negative. Whereas here, if I just switch the order, my first term is still positive. So it doesn't do anything to the signs to change the order of addition. So now we're going to get common denominators. So we're going to start by just setting it up. Just give yourself kind of something to work with. So 2x times x plus 2 times x minus 2. We're going to multiply that by something. Oops. Well, I don't want it to connect the dots. Stop. Plus 5 over negative x minus 2. Whoops, negative 1, x minus 2. I'm going to multiply that by something. And then minus 1 over x plus 2, which I'm going to multiply by something. So before we start multiplying, remember what we did before when we had a negative in the denominator? So 5 divided by a negative x minus 2 is the same as a negative 5 divided by a positive x minus 2. So that factor of negative 1, I'm going to put that in the numerator so that I don't have to do negative 1 over negative 1 and negative 1 over negative 1. Like, do you see how many factors of negative 1 you would have floating around if we tried to keep that in the denominator? So I'm just going to take it and make this a negative 5, which makes that a positive 1. right? So we're just taking the idea that a negative divided by a positive is the same as a positive divided by a negative. So 5 divided by negative x minus 2 is the same as negative 5 divided by positive x minus 2. So now, well, does everybody have a factor of x plus 2? Who's missing it? Yep, the middle term does not have a factor of x plus 2, so we're going to multiply by x plus 2 over x plus 2. And so now everybody's got an x plus 2. Does everybody have an x minus 2? Who's missing it? The last term. Good. So x minus 2 over x minus 2. So now everybody's got an x minus 2 and an x plus 2, which means that that first term already had the common denominator that I was looking for, and so I didn't have to multiply by anything. If you're really attached to it, like you can do 1 over 1, but, you know, I usually just get rid of it because multiplying by 1 over 1 doesn't do anything. So now, just like we did last time, we're just going to rewrite this whole thing over our common denominator. So our common denominator is x plus 2 times x minus 2. And I've got 2x plus negative 5. You guys mind if I call that minus 5 instead? It's just the same as subtracting 5, right? So minus 5 times x plus 2 minus 1 times x minus 2. Be really careful about making jumps to like getting rid of things like that factor of 1 or the parentheses. If we just say, oh, 1 times x minus 2 is x minus 2, and we write this, then we lose the distributing of that negative, right? So that's why I always write this step just exactly as it is above. And then you can drop parentheses later on if you don't need them, but it's better to write them and realize that you don't need them than to not write them and have a sign error. So now, again, remember, if you cancel at this point, you've done something wrong. So this whole thing is not a product, so I'm going to simplify it. So we've done all our denominator work. Now we're ready to do all our numerator work. So we've got 2x minus 10x. Whoops, sorry. That's 5x. Getting ahead of myself. 5x minus 10 minus x plus 2. So I just distributed there. And over my common denominator. This one works out really nice. So these can look like really messy, but a lot of times they just simplify down to something really nice. So 2x minus 5x is negative 3x minus another x is negative 4x. And then negative 10 plus 2 is negative 8. And I'm running out of room. We'll go over here. So now that we're done with all our denominator work, we're done with all our simplifying of the numerator. Now we're just back to where we were yesterday, where we want to factor numerator, factor denominator, and cancel common factors. So the numerator is negative 4 times x plus 2. And then the denominator is already factored, so we don't have to do anything there. And now I can cancel that x plus 2. So my final answer is negative 4 over x minus 2. So these, you guys can tell, these take some time, but I promise you that in the long run you will save time if you don't try to rush it and skip steps and smush things in. Just writing out every single step carefully and doing every single step carefully one by one is going to save you time in the long run, because you're not going to make like a really small like sign error that messes the whole thing up and causes you to have to go back and start all over again. So in the long run, it really does save time to just like be really methodical and write everything out really well. Not gonna lie, like they can get kind of tedious, but I promise it's gonna be more frustrating to have to do it 20 times than to just like do it the long way the first time. So your